Welcome! Today we're going to tackle a famous and beautiful integral known as the Gaussian integral. It's the integral of the function e to the power of negative x squared from negative infinity to positive infinity. Directly integrating e to the negative x squared is notoriously difficult because its antiderivative isn't an elementary function. So we use a clever trick. We square the integral. This means multiplying the integral by itself. Since the variable of integration is just a dummy variable, we can write the second integral using y instead of x. Now, we can combine these two independent integrals into a double integral over the entire xy plane. The integrand becomes e to the power of negative x squared times e to the power of negative y squared, which simplifies to e to the power of negative parenthesis x squared plus y squared. The differential element becomes dx dy. This form, x squared plus y squared, suggests a change to polar coordinates. Recall that in polar coordinates, x equals our cosine theta and y equals our sine theta. This means x squared plus y squared simply equals r squared. Also, the area element dx dy transforms to our dr d theta. The limits of integration also change. Since we are integrating over the entire xy plane, r goes from 0 to infinity, and theta goes from 0 to 2 pi. Now, let's substitute these into our expression for I squared. We get the integral from 0 to 2 pi with respect to theta of the integral from 0 to infinity of e to the negative r squared times r doctor. Let's focus on the inner integral with respect to r. We can solve this using a u substitution. Let u equal r squared, then do equals 2 r dr, or r dr equals 1/2 do. The limits also change. When r is 0, u is 0. As r approaches infinity, u also approaches infinity. Substituting these into the inner integral gives us the integral from 0 to infinity of e to the negative u times 1/2 do. The integral of e to the negative u is negative e to the negative u. Evaluating this from 0 to infinity gives 1/2 times 0 minus negative 1, which equals 1/2. Now we substitute this result back into our expression for I squared. We have I squared equals the integral from 0 to 2 pi of 1/2 d theta. Integrating 1/2 with respect to theta gives 1/2 theta. Evaluating this from 0 to 2 pi gives 1/2 times 2 pi minus 0, which equals pi. So we found that I squared equals pi. To find I, we take the square root. Since the original integrand, e to the negative x squared, is always positive, the integral I must also be positive. Therefore, I equals the square root of pi. And that's how we solve the Gaussian integral. This result is fundamental in probability, statistics, quantum mechanics, and many other areas of science and engineering. Thanks for watching.